Hello class, welcome to our lesson for today, dealing with the third day of linear and angular speed. Remember, my goal is to go over a few questions from the set of worksheet questions that are posted online or that you have. So I'm going to go over a few of those today to make sure that we're on the right track with those ideas. And then don't forget, if you have more questions, feel free to ask about them. I'm happy to look at them. The first question we're going to look at is number 1 on your day 3 information. It deals with the tires of a bicycle that are turning at a certain rate. And really, this question comes down to units and making sure they match up. Okay, so for example, the tires of the bike are 13 inches, but we're trying to figure out how fast I'm going in miles per hour. So I have to first take the 13 inches, get it into feet by 12 inches to 1 foot, and then get it into miles by 5,280 feet in 1 mile. Okay, you got to deal with that piece first. Once you've dealt with that idea, then you can use that new number for the miles. And that's the number you'll plug into V equals R omega, or velocity linear speed. So you'll have to change that radius to get into miles first. And then the other piece is that this is in revolutions per minute. Remember, every revolution is 2 pi radians, so you got to take that number multiplied by 2 pi. So if you take 215 times 2 pi, you'll get 430 pi radians per minute. But you need it to be per hour because you want miles per hour. So you're going to have to multiply that by 60 minutes for every 1 hour, and you'll get this huge number for omega, 25,800 times pi. But when you multiply that by the 0.000205 number, you'll get 16.63 miles per hour. So really, this question boils down to converting units, making sure all the units match up with the units you want at the end. Some of your homework and assessment pieces will also discuss that idea, so you want to make sure that you're paying attention to the units and how to find the answer. The next questions all come from number 4 of day 3 material. They all have the same directions. The Earth rotates on its axis every 24 hours. Assume the Earth's radius is 6,400 kilometers. These are all angular speed questions to start with. So per day, angular speed is, well, how long does it take the Earth to kind of go around one time? Well, it should be that many, 360 degrees or 2 pi radians per day. If you want per hour, you just divide by 12 and it would be pi over 12. Most of the time you want these to be in radians so that you can plug them into other formulas. Obviously, you could use 360 and divide by 12 for 24 to get 15 degrees. But typically you want them to be in radians for your answer. We're going to use that idea to find linear speed at different points on the globe. So omega for all of these questions should be 2 pi radians per day. If you want per hour, you'll use pi over 12 from this last slide. Okay, so realize that piece. And then the key is you have to think about it that you're on the axis, and then how far around would you actually be going on your spot. So if you're at the North or South Pole, you're at the very top or bottom. When you go around, you're not really moving. You're just kind of spinning like a top. So the radius at your location is 0. So you're not really moving. Okay, you're just standing in one spot spinning like a top. That's why that answer is going to be 0. As opposed to that, if you go to Ecuador, in Quito, for example, that's right on the equator, which means the equator idea, the radius of that spot is the Earth's radius, which is 6,400. So you take 6,400 times 2 pi to figure out that answer. Okay, so those are the two extremes. You're at the top or bottom, and that's 0 for a radius, or you're at the center or the equator, and that would be the 6,400, okay, for its radius. If you need it per hour, remember to divide by 24. The third question says, well, what if you're at Salem, Oregon, which is halfway? Now, I would never ask you a question that's difficult to find, okay, but in general, you can use trigonometry to find it. So here's what it looks like. So halfway up, basically, you're saying halfway between the pole and the equator, you're here, which means you have a 45-degree angle on both sides of this because it bisected the angle. So really looking at a 45, 45, 90 triangle, I could say sine of 45 equals x, which would be my radius, divided by 6,400. You multiply that 6,400 to the other side, multiply by sine of 45. That radius will be 300 or 3,200 root 2, or the corresponding decimal that you would find using your calculator. Times 2 pi radians per day, and you multiply those together, and this is how fast you're really moving if you're in Salem, Oregon, going around. Okay, so I couldn't ask anything unless it was 45, 30s, or 60s. You probably won't be asked something different than those three. But focus on those 3 types of questions. Number 1 being where are you at the poles, where are you at the equator, and then where are you at halfway. And that idea should be similar each time as you're looking at those questions. Okay, remember, if you have any issues with any of the word problems, I'm happy to respond back to you and figure some of those out. They correspond well to the homework questions. So your homework questions may give you a guided example as well that might be helpful for you. Remember, when you're looking at radians, in angular speed, that should be the angle divided by time. Linear speed should be r times omega, or it could be the arc length divided by time. Have a great day, everybody.